So we're looking at 1G, 2G, 3G, 4G, 5G. When it was 1G, we didn't know any better, so we were comfortable with it. When it became 2G, it became a bit faster, GPRS and Edge. Then 10 years later, 3G surfaced. Then 3G became faster. Then 2G became annoying. Then roughly around that same 10 years again, 4G came out. That was when we started using words like mobile broadband. That was when the concept of mobile broadband came in. Okay, and then on that 4G, the word LTE was introduced. 4G is just part of it. All right, so we're going to talk about the LTE, and then we'll move and talk about the 5G itself. So let's quickly look at LGE. Now your LTE, sorry, I kept saying LG, is LTE. Your LTE stands for long-term evolution. It was part of the 4G generation, or it was part of the 4G network that provides increased network capacity and speed. You're talking about more than 30 Mbps for upstream uploading, and then 100 Mbps for downloading. And LTE has been able to provide reduced latency, scalable bandwidth, backward compatibility to GSM and UMTS. That's the Universal Mobile Telecommunication Service. Now, the 4G LTE did not stop there. There are different, would I say breakthrough? There are different versions of it, because there's LTA or LTE-A, LTE-A. That's the long-term evolution advanced. Okay, the long-term evolution advanced has been able to provide up to 300 megabits per second. Whenever you see NB, yes, that's true. As someone said, when we're using BlackBerry, that's when you see those Edge and GPRS very well. True. There's a difference between when you see MB and both of them are capital letters, and when you see MB, one of the B is small letter. The same thing with GB. When you see GB and it's capital letters, that's gigabyte. That's for storage. When you see GB and the B is small letter, that's gigabit. That's for speed. That's why you notice that I have 30 Mbps, the small b. So that's 30 megabits per second. We know the conversion between a bit and a byte. It's 8 bits that make 1 byte, so that we don't confuse these statements that I'm making. Okay, so that's what LTE is about. Sometimes you notice that your network has 4G. Some other time you notice it says 4G LTE, because there are a lot of technologies in that 4G. Yeah, even though they all speak of the same thing generally, but some are faster than the others. Okay, now 4G features. 4G brought about audio streaming, video streaming, the real-time connection to services. Of course, it has a faster speed when we're talking about the LTE advanced. I remember mentioning just now, you're looking at 300 megabits per second. And as well, we talk about carrier aggregation. Let me describe what carrier aggregation is. It's an improved network capacity that merges bandwidths. It just merges bandwidths to give you a faster speed. If you have ever gone to the point where you check your phone and see how many bands is available on the phone, you can understand what I'm talking about. There are different frequencies that the phone operates with, even the network as well. Remember when we used to configure Symbian phones, and you see that the same MTN network has a couple of bands that it uses, 1-800, 1-600, and so on and so forth. So the carrier aggregation in 4G has been able to combine some of those bands and handle them and use it to provide a faster speed for you. That's what carrier aggregation is. It's a technique that is used in wireless communication to increase data rates by combining multiple carrier components. Okay, so these are features of your 4G LTE. Now the LTE as regards the Internet of Things, you look at here, it said in 2016, in June 2016, the company called 3GPP, it's not actually a company, it's a standard setting organization, 3GPP, the third generation partnership project. It's a unity of about 7 telecommunication organizations, the likes of ETSI, CCSA, and so on and so forth. They came together and they talked about the LTE MTC, in other words, called the IoT machine to machine communication. So IoT began to flourish better when 4G became a thing, when a standard was created for machine to machine communications. So the LTE machine type communication and the one called the narrow band IoT, NB-IoT, they are based on the LTE standards. Okay, I remember very well, there was a time I talked about the LPWAN, the low power one. The low power one is part of the machine to machine communication we talk about that uses LTE as its background. Okay, so that's your how IoT has been able to leverage on the LTE. Now under that, you notice that it provides the LTE-M provides 1 megabit per second for IoT communication, and then for narrow band it gives you 26 kilobits per second in downlink. All of this has been able to improve the communication of devices on the internet. Okay, and then it reduces the expenditure you have to think about as far as battery life is concerned. Of course, for a standard sensor that needs to be mobile, that needs to be able to perform what it needs to perform, you're looking at 5 to 10 years of battery life that it should have. And then when such a device is connected to a regular network and providing high data, providing high connectivity, you're looking at reducing that battery to 1 year or 6 months. So these technologies, the LTE-M and the NB-IoT, has been able to reduce this constant drain. Yeah, so it can provide you support for a battery life of 10 years on our regular AA battery, those 2 AA batteries. Okay, of course we know that it's not constant communication between the sensor and the hub or sensor and the gateway. It's a couple of seconds of daily activities. It's not every second or every minute or every hour that you are connecting and sending data. It is as at when needed. That's what 4G has been able to bring. Okay, here, okay, this is what I was referring to. Sensors and other devices that need mobility on the cellular network. You have the narrow band IoT network giving you 10 years of battery life, and then you have the LTE-M, 10 years of battery life as well on your AA batteries. Okay, those are the things I mentioned earlier. Now we're looking at examples of NB IoT, how it has been used or how it has been put to use in the industry. We're looking at smart metering for gas metering and water metering, consumer goods like white goods, tracking people. We've been able to achieve that with NB IoT. On the agricultural landscape as well, the environment monitoring, pollution monitoring, animal tracking, and so on and so forth. If you actually watch documentaries, you would understand, or you would have seen a couple of scenarios where birds are tracked across continents. birds attract from one continent to the other, from Australia to their nesting point or their mating place. This is IoT working. So I've been able to talk about that. So I've been able to understand smart cities, street lights, waste management. All of these are implementations of your narrow band IoT brought about by the 4G LTE. That brings me to the end of 4G and to the introduction of 5G. Last year, 5G sounded like the end of the world. The original design, the original intention of the creation of 5G was to bring about a better life, a better world. But it wasn't accepted immediately as it should be because of the conception of religious, or how would I put it, some religious inclinations to it. But the more people understand things, the more they get to accept it. So one of our tasks is to help people understand better. The 5G is fifth generation of cellular networking. It is the next step to mobile or in mobile technology. What are we looking at when we say 5G? What are we actually implementing? What are we actually talking about? We're talking about using higher data speed, faster speed. Between 3G and 4G, it is not a multiplication. Yes, there was an increase, but between 4G and 5G, there's a massive increase in speed. We're looking at moving from MB to GB, billions of bits per second, gigabits per second. That's what you're looking at achieving. And then if you check out what is written on my slide now, you see higher multi-GB peak data speeds. You have ultra low latency. One of the reasons why people had issues. Peace said this is 666. Yes. Now, one of the reasons why people had issue with 5G is this: when they hear radio wave, they assume it's bad, right? Even though our microwave uses the one that's worse than the one that 5G uses. But because you want low latency in 5G, you must have that connection. You must have that connection closer to you. So I know the distance between one MTN mast, and the next one there is farther, Abi. But with 5G, they have to be closer, so that the latency, the distance between one network and the other, is smaller. Now, in order to achieve that, there must be those 5G devices installed closer to us. People were scared of it already. That's going to create some form of cancer and so on and so forth. That was the first issue. But in order to achieve the kind of peak that 5G is meant for, that kind of infrastructure is needed. So increased availability and more uniform user experience to more users. That's what 5G promises, or that's what 5G is bringing. Because I can't be saying promises now, because 5G is already being implemented. It's no more a future thing. It's already available. It enables a new kind of network that is designed to connect virtually everyone and everything. It felt like they had IoT in mind when 5G was being created, because it's now giving you a chance to connect your devices, your machines, your objects, and everything. That's what 5G is enabling for us. Now, the underlying technologies that make up the 5G, it is based on what's called the OFDM, the orthogonal frequency division multiplexing. Later on, try and Google this so that you understand a little bit better. It's a method of modulating a digital signal across several channels to reduce interference. You're not using one channel anymore. You're using several channels. That's what makes it better. I would paste this on our WhatsApp group so that you can check out more information about that on your own time. Read more information, read out that, so you see more about 5G networks, because I'm going to limit what I'm talking about right now to IoT. That's the topic that's of interest to us. Okay, so looking at the IoT platform, the company, the organization I mentioned earlier, 3GPP, came up with a project, or started a project called SMARTER. SMARTER is a short form for Services and Market Technology Enablers. Now, the study called SMARTER has 3 objectives, and the 3 objectives of the SMARTER is this: enhance mobile broadband, the EMBB, the ultra reliable low latency communications, URLLC, and the massive machine type communications, as the MMTC. I'm going to just see how fast I can run through the 3 of them, because we are already running low on time, so that we can meet up completely. Now let me bring back the slide. Okay, so here on a short definition, the first one says is data driven. Second one here is talking about low latency communications, and the third one is talking about machine to machine communications. That's where our IoT enjoys a lot of progress. Okay, so now let's look at what we are trying to achieve. In 2015, that's their SMARTER project came up with over 70 use case scenarios. Those scenarios are what we're categorizing into the 3 objectives: the EMBB, the URLLC, and the MMTC. Now let's look at what we were able to achieve, or what we are going to be able to achieve when we tap into this technology. Now you have enhanced mobile broadband. You either call it enhanced mobile broadband or extreme mobile broadband. One of the 3 primary 5G new radios. Okay, it is something that enables a massive capacity for network, giving you multi gigabits peak rates, allowing 100 plus megabits per second per user experience. Now let me explain this. If you have an internet that promised you to have 100 Mbps, that 100 Mbps, if 2 people connect to it, that network has reduced. If 10 people connect to it, that network has reduced. But this is promising multiple 100 plus Mbps per user. Do you understand the difference now? So that's what we're looking at. And then if we're not talking about the EMBB, that's the enhanced mobile broadband, we're looking at the ultra low latency communication, because the distance between one radio and the other is not far. So it gives you a throughput speed eventually to be as much as 200 gigabits per second. All right, so that's what we're looking at. Yeah, looking at enjoying from using that 5G technology. The next one here says the massive machine type communication. That's the one on the left that says massive Internet of Things. You either call it massive machine type communication, or massive machine communication, or massive machine to machine communication. It's talking about our sensors talking to each other. Okay, so data generation, information exchange, and actuation takes place within a minimal or no intervention from humans, but then a higher connectivity, a higher progression from where we were before. Now we're no more looking at the Internet of Things, we're looking at the Internet of Everything, because with the capability of 5G, you can connect virtually anything to the internet. Now the low latency is not just low. Now you're looking at ultra reliable low latency communication. Okay, the use case scenario for that is in the area of sensor grids, the dense sensor grids, the smart grid, electrical power, the transportation, augmented reality, healthcare. These are the implementations of the URLLC. I hope we can still understand what I'm saying. Is anybody totally confused? Because the technology is new, there's no how would I put it? There's no already made things that we're doing right now that I can use to give you examples. Until Nigeria gets to the point where they start implementing 5G, probably by that time we'll change phones as well, because the technology we use now, the 4G, is embedded in the phone. So if you want to tap into 5G, you must at least upgrade your device to support such things. Okay, but moving forward, the next chart I have here, the 5G user scenarios. Because of the massive speed and enhanced smart home, smart building, smart city, the here he talks about future IMTs. What does the IMT talk about? It's international mobile telecommunications. That's what the IMT is about. You're looking at 3D videos, UHD screens, working and playing in the cloud, augmented reality. All of this is being enabled by these technologies. The third chart there is still referring to the same thing that the second slide is mentioning. Having the three core aspects of the 5G network, the three core radios: the enhanced mobile broadband, the massive machine to machine communication, and the ultra reliable low latency communication. Now let's look at practical scenarios. I'm sure later on we can understand this better when I talk about those practical scenarios, these use case scenarios. Now think about it like this: has anybody in this class hello, Dewali said my voice is breaking. Is anybody else experiencing this? Okay, Tony says it's okay. Dewali, that means your network is already acting up. Try refreshing immediately so that we can continue. I need you to be with me for this use case scenario, because the use case scenario explains most of what we have been talking about since. Now the question I was asking now: has anybody ever gone to watch the Nigerian match at the stadium? If you have, can you indicate so that I can ask you some direct questions, so you can help share your experience? Have you ever gone to watch a Nigerian match, a very crowded stadium? If you have, you would understand that your network is divided by 2, if not divided by 10. The network connectivity you have that you used to enjoy, by the time you see that crowd in the same place, we're looking at 20,000, 30,000 people, the network there becomes so bad that you can barely make a call. If you have ever been to a stadium, a filled up stadium, and you experience this, you bear me witness. And that's not all. Remember, there was a particular time that Glo did this AWOF 5 times. The first time they did that AWOF multiplied by 5. If you load 1,000 naira, they'll give you 5,000. Networks jammed. The network jammed because everybody was making call at the same time. Meaning network was bad. Everybody was using the bandwidth. The network went down. Now the reason why it goes down is because the throughput, the available band has been utilized by people. So now let's look at what your 5G scenario or 5G network will bring for us. Now think about a stadium filled with people, thousands of people, all connected to the internet. Most people trying to record and share a video to stream it live, and so on and so forth. Now the first one we talked about, the enhanced mobile broadband, the EBB, can handle such kind of hotspots. Those places are known as hotspots because it is not an everyday thing. It is not a daily event. That particular 90 minutes, that area will be like that. So in situations like this, the network providers will be able to identify that place as a hotspot at that particular time and devote a lot of resources to those particular regions. Of course, you remember we talked about the low latency, so there are radios around. Okay, so not only will fans be able to enjoy seamless connectivity, but the organizers will have opportunities as well. So remember that if I can get a very fast internet around the stadium, it means that there's nothing stopping me from having a channel where people watch that match through me live. Okay, so you have organizers who have new possibilities to create a better fan experience. Enhanced video capabilities combined with improved network capabilities, giving the fans some real-time mobile access to instant replays. If you ever try to watch some Champions League matches online, you can understand this. So in such places, more network capability is devoted. You actually test the 5G broadband itself to understand how fast you can go. So resources can be retaxed to make sure that the experience of users around that space, around that time, is seamless, is enjoyed, creating more opportunity for the stadium owners, the event planners, the operators, the professional sports franchise, media companies. You see a world of opportunity that this is opening for people. Okay, so these are the things that 5G is doing for just that sector, for just that sector alone. Now let's talk about safer cities, smarter cities. Okay, so think about there was a particular time I talked about IoT as related to health, traffic, and I remember mentioning an example: an ambulance leaving the hospital to get to a particular destination. And how would they be able to know the faster route to follow if they are not aware of all the traffic in the city, all the routes they are going to follow, all their traffics, and how it is? The only way to achieve this is to have devices that get information from pole to pole, gathering information from shorter distances, and then feeding it to a central system that anybody can tap into. So if there's an accident let me use Abuja as an example. If there's an accident in central area, all the routes leading to central area already has that data existing, and that data is fed to one central system, and that central system will be able to give an insight on what will happen. So the police should be able to understand the best way to follow, the ambulance understands the best way to follow, the tow truck that will help clear the road safety understands the best way to follow, all coming from their different environments and all converging at the point to make things easy. You understand what we're talking about now? So when there's a car chase, there's a police, there's an armed robbery situation, and the person just reports it from one particular junction, all the cameras in the different areas surrounding it should be able to give you information, give you feedback. Those things we watch on the movie, where they say, okay, where was the last point? Where were they last seen? They mention the street name that they passed, and then the next camera is already capturing and then relaying the information back to a central point. Then the police is using that kind of information to track. Now that's what the 5G is enhancing. Imagine trying to manage 4G, and the camera you want to put is in between the first mast, which is in a very very far place, and the second mast, and in that center the internet is not strong enough. You run out of the road and run into a place where there's no network, no more communication. That camera cannot capture and send immediately. You understand where the low latency making it possible for you to deal with a lot of things, making it possible for you to enjoy technology the way it is. So that is what we are looking at. Hopefully we'll have more enthusiastic people who go into this field, help us, help Nigeria bring the information down, bring the devices down. I remember the first time Abuja was connected, the Abuja city itself was connected with CCTV cameras. To steal a car, even a vigilante will catch you, because it's all about connecting to the emergency system, and then they discover where that car passed. But then a couple of months later, the resources, the cost of resources, because it's 4G, so the resources that you are deploying has to be much. So the cost of it would eventually weigh down the system. And at the end of the day, a few cameras would have gone off already, and then the remaining ones are still being put to minimal use. Yes, but the more technology is improving, the more people like you are learning, the more you can provide better solutions to the country, better solutions to the environment. I know estates that use some of this technology already, not 5G, but the technology of Internet of Things. They use it to deliver security, emergency services, and so on and so forth in their own little or small estate. So that's what we're looking at, or that's what we hope to get into in the nearest future. Talking about what we have been able to achieve today, we've been able to understand today. At least we have been able to understand what the 4G LTE is. We have been able to understand the introduction to 5G, what 5G is all about, and how it relates to the IoT ecosystem. We've been able to hear about the Smarter project, and under the Smarter project, we understood the three categories: the enhanced mobile broadband, the massive machine type communication, and the ultra reliable low latency communications. And I've been able to paint some use case scenarios. We are saving the other use case scenarios for the future. Now, before I sign out today, I want to show you a typical example of how you can create simple systems. I'm going to switch from the slide I'm sharing to my screen so that we can see exactly what I'm seeing. So let me switch from this to give me a couple of moments so that I'll get that up. Okay. Okay. All right, so let me go back to this. Okay. Let me get back my camera. Okay, so now this is a device. Let me use the property. This is a robot. Okay, and on the robot you can see a couple of sensors. I remember I showed you this sensor before. I showed you this particular sensor in front before. The ones I'm touching. The video feed takes a little bit of time to get to where we are. So you'd forgive me a little bit. We're still managing the 4G network. If it was 5G, we should have a faster speed. Okay. Now, what all the device is doing for me is this: that I have codes embedded into it that tells me whenever there's somebody that's walking around it, or there's somebody that comes that impedes the line of view of the device. That means equivalent to saying detecting, that the device can detect somebody who's in front of it. All right, now that's what this is achieving. So I've been able to program this robot to detect when somebody is around. I don't know if you can hear the sound. If you can hear the sound, you notice that when I put my hand in front, the sound comes up. This is a simple implementation of the motion sensor. So when someone moves in front of the sensor, it captures it. Remember when we talked about sensors? There's motion sensor, there's proximity sensor. Now this sensor has been embedded with some form of proximity sensing and motion sensing. Okay, so all of this is what we're going to be preparing for in our physical class. I understand that some of you don't have programming backgrounds, but we're going to do some form of basic programming, even if it means me bringing some basic block programming, and then we can now move forward to the text-based programming. I'll do that. I'll ensure that we achieve that. Now, from what we have achieved today, do we have any questions? With what we have talked about today, do we have any questions? If you have any questions, can we get the question? Samuel, do you have a question? Okay, Samuel has a question. Samuel, you're connected to the mic. Yeah. See, with speed comes consumption. Do you know why I said that? If your internet is slow, it means that it runs at a slower pace, right? It means it consumes less data. Sometimes you even get annoyed and you don't watch the video you want to watch. Cool? But with a faster speed, do you notice that whenever your phone is connected to Wi-Fi that is very fast, it starts downloading things. It starts doing updates and the rest of them. Now, that's the same thing that happens between the 4G and 5G. If you were using 3G, right, 1 gigabyte might be enough for you for almost like 1 week or 2 weeks because of how slow the internet is. Not because when compared to 4G, the data runs faster, no. Or because of how slow the internet is, you do less. Do you understand? You do less because the internet is slow. But when the internet becomes faster, that's when you see people watching more videos, going there, doing the Facebook thing, the Instagram thing. And because the 5G network is faster, the internet, your data use will still be faster. But if you stick to your normal routine, for example, for those persons who don't watch videos, right? For those persons who don't watch videos, then you notice that you're still using the same data. Joy is asking, why does iPhone consume more data than Android? The background services for iPhone is a lot more than the background services for Android. That's the reason why even when your phone is off, even when an iPhone is off, there's still a constant communication between the phone and the iCloud. It's the reason why the phone cannot easily get lost, because there is a steady connection between the phone and the cloud itself. That's steady maintenance is a problem. It's data you're using. Although, if you notice very well, Joy, if you notice very well, they gave you a setting that you can turn on what connects to the internet and what does not connect. That means you can go to those settings and choose which of your apps should connect to the internet by default, or the one you want to be the one to turn on by yourself, giving you the opportunity to reduce what is connected to the internet. Android does some form of it. For example, if you open Instagram and leave it open, it tends to browse the phone will browse the Instagram by itself and save some of the pictures for you, save some of the images for you. Facebook does that as well. If you load Facebook, it will load a lot of things that even if you disconnect from the internet, you can still check out Facebook. You can still go through your Facebook when internet has turned off, because it has downloaded some of those things, now giving you the opportunity to browse it offline. That's what leads to the consumption. Now, the reason why we suffer more down here in Nigeria is because of the conversion, the dollar conversion rate, right? So the cost of internet up there in the West, in US, in Russia, the cost of internet up there and the cost of internet down here, the difference is that conversion rate. That's why when the dollar, if the dollar drops to $1 and £1, our internet use is very cheap. Our internet cost will be very cheap, because the persons who own the infrastructure we are connecting to, that's using the global standard to charge us, will now, of course, charge us the way it should. And then when a competition comes that can drop that price, then you watch the price drop again. Remember how much we used to pay for a few gig of data until competition started coming in and the price started going down. Now, this is what leads to it. And then when 5G implementation comes, of course, companies will want to be in the forefront. When companies be in the forefront, we pray that it's not just one company, like the way MTN used to do us in the past. I remember in 2004, I got an MTN SIM for 33,000. The smallest card I can load is 1.5 per minute. You're spending about 50 naira, 100 naira per minute until competition came, and then the prices came down. So we hope that when 5G is being deployed, we will not start from beginning again and it's only one company that has the capability. When so many companies come at the same time, the price tends to go down. So we're hoping that one of you would have that connection to Dangote or to Otedola, that when you finish learning and you start deploying things, we can get the services, and then Nigeria would push on to greater heights. So are there other questions? There are other questions. Let's tackle them now. We have just one more class, and then after that class, you should have that 1 week break before the physical class, so that we can come and practicalize some of these things that we've been talking about. If there are no questions, we'll call it a day. We have stopped doing the assessments. So what I'm teaching you right now, I'm hoping that you are getting it, so that when we resume the physical class, we'll not have to go back and start talking about things we've talked about before. In our next class, we will just look at I said I was not going to talk about protocols because we have dealt with protocols before. In our next class, we'll just talk about the end-to-end devices, machine-to-machine and userless communication, the dynamically distributed cloud, end-to-end security, and then industrial automation platforms. I think that's just it. In physical class, we can talk about the remaining ones, the use case scenarios, and the rest of them. So thank you very much for joining my class today. Thank you for making our time today to join the class. We hope that we would see you on Saturday, which is our last virtual class. And then I'm finding it difficult to be happy because I'm getting people telling me that they will not be available for the physical class. I don't know how you can do it, but try and make yourself available for the physical class, because I'm not happy about the fact that we are supposed to be 49, but I have give or take 15 to 20 people, and some of those 15 to 20 are already engaged with other activities. Let's try as much as possible to be available for the class. Thank you once again for being with us. Thank you once again for joining the class. We'll see as much as possible. I'll make some resources available for you to get a programming background. Even if it's starting very small, you can start very small. Joy is asking, are we doing any form of assessment after the physical class? The physical classes are practical, so I expect that we're going to get it. The assessments will be in the physical class. It will not be after the class. We'll just be doing it as the class is going on. Okay, so thank you very much for today's class. I hope to be with you again on Saturday, and then be with you physically in 2 weeks' time. Have a lovely day. Thank you so much.